at the process of the implementation of the Wi-Fi base indoor positioning system. Session is started to use the IWList command. What the IWList does is it is a scanner for all surrounding access points with their respective measurement values. So we can take a look here. We will notice all the APs and all the measurements that are respective to each MAC address. What we will do is we will highlight the MAC address and copy it to the program. First off, we'll take a look and see how the program works. First of all, we take a look at the imports. We import the stop process, the RE, the MAT, and the localization. All these will be used to make use for the project and how the code will delve into getting all the required fields that we need. First off, our first function gets all the, it will carve out each and every field that we need. Here is the signal where it will check from the IWList command where the MAC address that we found, it will get the MAC address and append it into the array called signal strings. The same will do for the MAC address for the MAC address and the frequency. Secondly, what this will do is there is a counter preset to 0 where the frequency and the RSSI are variables which are preset to 0. This loop will then loop over the MAC address until they match with the MAC address that we will give to the program, and it will get the frequency and put it into FREQ as a variable and the signal strength as a RSSI. And we will return them because we will be using them later on. The second function will give out the free space path loss method formula, where here we are returning the float frequency since we need it in megahertz and we times it by 1000. The variable formula will hold all this line of the free space path loss formula, and then the total distance will hold the MAT to the power of 10 of the formula. And we return that for total distance so we can calculate the distance when it is converted into the localization algorithm. Here we get the IWList scan, and we see that in the line we have to print them all out. Here are the MAC addresses where we highlighted before of each AP MAC address which will form the trilateration method. Here is the localization. Here is where the localization algorithm starts. We use the solver LSE in comparison to the CCA as it is more accurate. And we add the anchors, which are the AP MAC addresses, where here you have each and every AP MAC address in a slot with its corresponding location. We then put the frequency and RSSI that we got from the first function, and we put in the get RSSI from MAC, which is the one up on top as well. We print them, and then this is done so errors will not be shown. Other than that, the add measure is part of the localization algorithm where the MAC addresses will print that of the distance, each MAC address will print its own distance, and the p.solve will solve the location of the APs together where the user's location is. And here we will print the location, x-axis and the y-axis. This is how the code will work out. Here it is checking the IWList command, it is running it, and it will get the MAC addresses that we preset into there. And as we can see, we get for the MAC address, we get the RSSI value, the frequency value, and the distance away from us. And with that, the LSE geolocating localization algorithm will give us the exact an estimate